All right, so this is Chapter 8, Section 4, Angles of Elevation and Depression. Our objective is to use angles of elevation and depression to solve problems. So I liked the picture better than any of the word definitions. So I did pull the word definition out. An angle of depression is the angle from, so you take your item, your spot, and create a horizontal line, and then it's the angle from that horizontal line to what you're looking at. That's the angle of depression. An angle of elevation is the easy one to see. It's from the ground. The ground is your horizontal line, and it's the distance, the angle up. So if we were to identify it here in problem 1, what is the description of the angle as it relates to the situation? And shown, angle 1 is right here. He has a horizontal line on top, so he must be an angle of depression. Angle 4 is from the ground, so he is looking up, so he is an angle of elevation. So let's look at our got it problem. Use the diagram in problem 1, so that's this picture. What is a description of the angle as it relates to the situation? So if we look at angle 2, there's only 2 options. Angle 2 is either angle of depression or angle of elevation. What do we think? Angle 2. Are we looking up or are we looking down? Yeah, because we're looking up. So this would be angle of elevation. And angle 3 is right here. He is looking down, so he gets to be the angle of depression. Okay, so let's apply this. You sight a rock climber on a cliff at 32 degrees angle of elevation. Your eye level is 6 feet above ground. So from here to here is 6 feet. And you are 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? So we are going to find out this little x value. So you select this is your angle of focus, 32 degrees. We have the opposite side and the adjacent side. I actually don't have any information about the hypotenuse. So opposite and adjacent is tangent. And that is x over 1,000. So to solve for x, I'm going to multiply both sides by 1,000. And on my calculator, it's going to be 32 tangent times 1,000. And that's 624.8. I'm going to round to the nearest foot, so that's 625. So I know my x value is equal to 625, but I am actually 6 feet above on top of that because it says your eye level is 6 feet above the ground. So if from your eye level to the climber is 625, I need to add 6 feet. And your total is 631 feet. Okay, let's look at the second problem. An airplane pilot sights a life raft at 26-degree angle of depression. The airplane's altitude is 3 kilometers. What is the airplane's horizontal distance d from the raft? Always, always, always make a picture. Without a picture, this problem is nearly impossible. So the first thing I did was I drew a picture. And so the star is the airplane. The life raft is this circle here. So angle of depression means that we're looking down. So I have a horizontal line, and I'm looking, my eye level is looking down the 26 degrees. The airplane's altitude is 3 kilometers, so the distance from the airplane to the water is 3 kilometers vertically. And then the horizontal distance D is marked here in red. So we have, if this is our angle of focus, we have an adjacent side and an opposite side. So we have a tangent situation again. And that is opposite over adjacent. When I get this scenario, I always go, oh yeah, I'm going to put it over 1. So when I have a variable in the denominator, I put my tan sine or cosine over 1, and then I cross multiply. So I get d times the tangent of 26 degrees is equal to 3 times 1. To solve for d, I have to divide by tangent of 26. So on my calculator, that looks like 3 divided by 26 tangent equals 6.15. So we are 6.15 kilometers. And just a way to double check this, the distance is in the same category as my 3 kilometers and 6.15 kilometers. They're kind of in the same realm. If I had a million kilometers shooting back out at me from the calculator, that would indicate that I might have something wrong with my calculations. All right, so that's section 4 of chapter 8.